You know how a simple sketch on a napkin can somehow become a real functional building? Well, there's this hidden, absolutely crucial phase in between. It's kind of like a secret rehearsal where all the big ideas get tested, refined, and coordinated. Today, we're going to pull back that curtain and uncover the secret language that turns a simple drawing into a full-blown symphony of design.
All right, so here's our roadmap. First, we'll talk about what this rehearsal phase really is. Then we'll shadow the architect to see their master plan. After that, we'll meet the entire orchestra of designers, see how they all work together to build smarter, and finally, we'll check out the finished design package that makes it all official.
So just think of an architect as the conductor of an orchestra. This phase we're talking about, what the industry calls design development, is where that conductor brings the entire orchestra together for the very first time. It's not the final performance, not yet, but it's where every single section learns its part and, this is the important bit, how to play together in perfect harmony.
So what is design development, or DD as you'll hear it called? It's really the bridge that takes you from a cool concept, that approved sketch, to the super detailed blueprints for construction. This is where the big ideas get real. The team figures out the exact dimensions, they pick out the actual materials, and they map out how all the complex systems, like heating and power, are going to fit and work together. It is all about intense coordination.
Now, during this phase, the architect isn't some lone genius sketching away in a tower. No way. They are the central coordinator, the conductor, holding the musical score for the entire project. It's their job to make sure every single decision, from the tiniest detail to the biggest structural choice, all aligns with that one unified vision. The architect's role here is just a masterclass in juggling. I mean, they're not just defining the look and feel, they're deep in the technical weeds, making sure the budget actually works with the materials they want. They're the one person who has to see how the fire safety plan impacts the engineering and how both of those things affect what the client actually wants. They are, without a doubt, the ultimate project integrator.
Of course, a conductor is nothing without their orchestra. And in architecture, that orchestra is the design team, a whole group of specialized consultants, where each one is a virtuoso in their own field.
Modern high-performance buildings rely on something called the integrated design process, and it's a game changer. This is not a relay race where the architect just hands off a drawing to the next person. Think of it more like a collaborative jam session. Everybody, structural, mechanical, electrical engineers, they're all in the room from day one, brainstorming so that their systems work together seamlessly instead of clashing down the line. First up, let's talk about the structural engineer. If the building's a symphony, these folks are the rhythm section. They're the percussion and the bass. They provide that fundamental frame, the solid, sturdy backbone that holds everything else up and gives the building its core strength.
So this means they're calculating the size of every single beam and column to handle anything from heavy winds to earthquakes. But here's the really tricky part. They have to build this super strong skeleton while leaving perfectly placed holes and pathways for all the ducts, pipes, and wires that the other teams need to run through it. It's like a massive high-stakes 3D puzzle.
Okay, this is where the building starts to feel almost like a living thing. The mechanical engineer designs its lungs. That's the heating and air conditioning, and its circulatory system, which is all the plumbing. They're totally focused on keeping the building breathing and making sure everyone inside is comfortable. These engineers are asking the big questions. Exactly how big does the AC unit need to be? Where can we possibly run these huge air ducts without smashing into a structural beam? And the energy models they build don't just predict the utility bills. They directly shape the building's design to make it as efficient as humanly possible.
All right, next up we have the electrical engineer, who's basically designing the building's nervous system. They're responsible for literally everything that uses power, from the lights that let you see to the data cables that get you on the internet. They're the ones who bring the building to life with energy. And their job is so much more than just adding up the power load. They're designing lighting that feels good to be in, and they're planning the hidden pathways for everything from fire alarms to security systems. And that coordination is absolutely critical. Their systems have to talk to the mechanical systems to create smart, energy-saving controls.
Now, a building doesn't just float in a vacuum. It sits on a real piece of land, and that is where the civil and landscape team comes in. Their job is to set the stage, to integrate the building perfectly with its environment, both what you see on the surface and all the important stuff underground.
This team handles everything connecting the building to the rest of the world. They manage the invisible connections, the water, sewer, and power lines, and the visible ones, like how you'll drive in and where you'll walk. They design the entire experience from the street to the front door, shaping everything from drainage to gardens. So you get this whole orchestra of experts playing together from the very beginning. What's the payoff? Well, the result is that they can create a building that's so much smarter, more responsive, and way more sustainable, all because they made the big decisions together. This right here shows the fundamental shift. In the old days, an architect might design a gorgeous, all-glass wall and then turn to an engineer and say, okay, figure out how to cool this thing. In an integrated process, the energy cost of that glass wall is part of the very first conversation. It influences the building's shape and materials from the get-go, leading to a much smarter outcome.
And here is a perfect example of that. It's so simple, but so brilliant. By just analyzing how the sun moves across the sky during the year, the team can add simple overhangs and fins to the outside of the building. This one elegant design choice can block the harsh summer sun, which dramatically cuts down on how much energy you need for air conditioning. And as a bonus, it lets in all that free heat from the low winter sun. In an integrated design, no surface gets to be lazy and do just one thing. I mean, just take the roof. It's not just a lid anymore. It can be a power plant with solar panels, a garden that manages stormwater, a light source thanks to skylights, and a water collector for the landscaping. Every single element is working overtime. Okay, so after all of this intense collaboration, this back and forth, what's the actual tangible thing you get at the end? The team assembles the complete design development package. This is it. This is the finished musical score with every note for every instrument written out, ready for the client to give it the final sign-off. This package really has three main parts. First, you've got the drawings, which are the what, the visual plans, what it's all going to look like. Then you have the outline specs. That's the how, a super detailed shopping list describing the quality of every single thing, from the bricks to the boiler. And finally, there's the design report. That's the why, the story that explains the logic behind all the design choices. And this right here is the whole point. The goal of these documents is to finalize the design before any more work happens. This package is the final checkpoint. The architect gets that formal, written approval from the client, which locks in the design before they move on to the next, even more detailed phase, creating the final construction documents. So the next time you walk into a building that just feels right, you know, the light is perfect, the temperature is comfortable, it's quiet, it's just easy to be in. Take a second. Think about that invisible symphony of decisions, the incredible coordination between all those architects and engineers that had to happen to make it all work so effortlessly. What parts of that hidden